All right, so today we are going to talk about some operations with matrices. Okay. Uh, the first thing I want to talk about is matrix equality. Two matrices are equal if their corresponding entries are equal. Okay. What what probably needs to be true about the order of A and B if they're equal? They should probably have the same order, right? That kind of seems like common sense, right? You're going to get some problems that look like this. What is X? What is Y? You got it. Two matrices are equal as long as their corresponding entries are equal. The next thing we're going to do is matrix addition. Okay. If you were to take a guess about matrix addition, what do you feel should be true about the order of A and B? If I'm going to add two matrices together, what do you think should be true about them? Their order needs to be the same. We can only add or subtract if our matrices have the same order. If they do not have the same order, we say that the sum is undefined. So if I give you two matrices to add together and they do not have the same order, you're going to tell me that it's undefined. In order to add matrices, we're going to add corresponding entries. So the number in the first column, first row is going to be added to the number in the first column, first row. And that's where it goes. So we'll do some of the examples, but I want to talk about one more thing before we do. We have something called scalar multiplication. Now we will talk about matrix multiplication, but right now I want to talk about scalar multiplication. When we talk about multiplying by a scalar, we're multiplying by some constant. Okay? So if that is the case, then we're just going to take that scalar and multiply by every single entry. So if you have a number being multiplied to your matrix, each entry gets multiplied by that number. Is basically what that is saying. Okay, so I'm going to write two matrices up here. I want you to go ahead and write them down. That way when we perform some operations, you have them to refer back to. Okay, now matrices are always named with a capital letter. All right, so here I have matrix A and matrix B. They are named with capital letters. Okay. So go ahead and write those down so you know what I'm referring to when we talked about some different operations. What is the order of A?
3 times 3.
And what's the order of B?
3 times
Okay. So are we allowed to add A and B? Yes. Okay, they have the same order, so we can add them. So when we add them, what we're going to do is add corresponding entries. So we're going to take 2 plus 2 and 2 plus 0 and 4 plus 0 to get our first row of 4, 2, 4. Now we're going to move to the second row. The second row, negative 3 plus 1 and 0 plus negative 4 and negative 1 plus 3. Yep. Thank you. All right, and then what would our third row be? I heard 5. I don't know if you said 5. I don't know what I was thinking. There you go. 1, 4, 4. Can you handle it? Yeah, that was nice, right? Okay, now I want to find negative 2b. How do we do that? Multiply negative 2 to each number. So, negative 2b would be negative 4, 0, 0. Second row would be, help me out. Excellent. And row 3. Excellent. And then you're also going to get problems that look similar to this. 3a minus b. So we have a couple operations that we need to do here. Okay? While you're getting used to this, I would do one thing at a time. So first, let's focus on 3a. How would we write 3a? You have that written down, so I'm going to trust you. What is 3a?
6. 12. Negative 9. 0. Negative 3. 6. 3. 6.
That is 3a. And we're going to subtract b. Is that b? Did I get that down right? Okay. So here's 3a, and we're subtracting b. So our first row becomes what? 4, 6, 12. We take 6 times 2. 6 minus 2. 6 minus 0. 12 minus 0. Second row. Negative 10. Try again. 0 minus negative 4. There we go.
0. Negative 6.
Negative 6. Okay. If, okay, this is a good thing to think about. if you would rather distribute the negative and make an addition problem because you're worried about that subtraction, that would be fine. Okay, that might be a good idea. All right, third row. 7. There it is. Okay, can you handle it? All right, now, matrix multiplication is not as straightforward as these operations. We're going to have to do a little bit more work, okay? That's all right. We're not afraid of that. So, here is the rule. If matrix A is m by n, and B is n by p, then the product is going to be n by p. Okay. A is n by n. B is n by p. So their product becomes n by p. So I'm going to write this. Our first matrix is this order. Our second matrix is this order. If we want to multiply matrices together, the columns of the first matrix need to match the rows in the second matrix. It looks like that a little bit. It looks like that a little bit, okay? That way, because what we're going to do, we're going to multiply row times column, row times column. All right, so we need these to match up, and then our resulting order is the rows of the first and the columns of the second. Okay. Please do not write this all down, but what I want you to write down is that matrix multiplication is row by column multiplication. What we're going to do is we're going to multiply row times column, row times column. And that is why this right here is important. So what we're going to do is we're going to multiply a row times a column, and we're going to add those numbers together for one entry. So if we take the second row times the third column, the sum of those products gets placed in the second row, third column. If we take the first row times the first column, that's going to give us one entry to put in the first row, first column. Okay? So, please go ahead and write this down. Okay? We're going to learn this by example. Okay? What is the order of A? And what is the order of B? Since these are the same, we can multiply them together, and our product is going to have what order? 3 by 2. Okay. So now what we get to do is we get to take each row times each column. So we're going to take the first row times the first column, and we're going to multiply -1 and -3 and 3 and -4. So what I want you to kind of imagine doing is taking this row and lining them up with this column. And we're going to multiply those together. So we're going to take -1 times -3 and 3 times -4. And that is going to be one entry in our matrix. And then we're going to take the first row times the second column, and we're going to do the same thing. We're going to take that row, and we're going to match it up with the numbers in the columns. So we're going to take -1 times 2 and 3 times 1, and we're going to add those numbers together. And since we multiplied the first row with the second column, we're putting it in the first row, second column. Okay. So now, we've multiplied the first row by all of the columns. So now we can move on to the second row. So now we're going to multiply the second row to the first column. So I want you to imagine lining these numbers up. So we're going to take 4 times -3 and -2 times -4. We're going to add those together to be our second row, first column, because we multiplied this second row to the first column. And then we're going to take second row times second column. Imagine lining these numbers up. So 4 times 2 and -2 times 1. And we're going to add those numbers together in this second row, second column. And then again, third row, first column. Imagine lining those numbers up. Okay, so we have 5 times -3 and 0 times -4. And that goes in the third row, first column. We're going to add those together. And then we can take third row times second column. Imagine 5 times 2 and 0 times 1. And so then we can put that in the third row, second column. So then when we add those numbers together, there is our 3 by 2 matrix. So we take 3 plus -12, get -9. And we have -2 plus 3 to get 1. And so on and so forth. Yes.
Just for the first one, because 4 times -3 is all 1. -2 times 4.
What are you talking about?
For the answer, second row.
Here?
Yeah, shouldn't that be
So
a
this is -12.
plus?
Mm-hmm.
Oh, wait. My bad.
It's all right. We thought. Okay. So let's do another problem. We're going to take A times B. Go ahead and write A and write B. What is the order of A? And what is the order of B? 3 by 2. Can we multiply these together?
Sure.
Yes. And what is our resulting matrix going to be? So A times B is going to have an order of 2 by 2. Okay? So let's take A times B. Okay? Let's start with first row, first column. We're going to match these 3 numbers up to here. What is 1 times -2? Plus 0 times 1. Plus 3 times -1. Okay? That is all one entry in the first row, first column. Then we have first row, second column. We're going to multiply these three numbers to these three. So we get 1 times 4, 0 times 0, and 3 times 1. And that goes in our first row, second column. Okay. Can we do anything else with our first row? We have run out of columns. Let's go to the next row. So second row, first column. We're going to get products of -4, -1, and 2. And since we multiplied the second row to the first column, that entry is in the second row, first column. Okay. And then finally, we're going to take the second row times the second column. So we're going to match these numbers up. 2 times 4, -1 times 0, and -2 times 1. Since we multiplied the second row times the second column, that is where that number goes. Second row, second column. Okay. So our 2 by 2 matrix is -5, 7, -3, and 6. Would we get the same thing if we multiplied B times A? We would? Yes. The order would change. You told me that B was a 3 by 2 matrix and A was a 2 by 3 matrix. What would be the order of B times A? 3 by 3. Is that going to be the same? No. Okay, so matrix multiplication is not commutative. A times B is not B times A. There are some very few cases where it does work out, but a lot of times you're going to be able to multiply A times B, but not B times A, because the order is not going to be okay. All right, so you need to be careful and make sure you label your orders so you know whether you can multiply them together or not. If you cannot multiply them, what do you say?
Undefined.
Undefined. Very good. Okay. How important is your homework going to be?
Very.
You have to practice this, otherwise you're not going to get it. Once you have it, it's plug and play, right? But you got to practice the order.
How much of like the steps do you want to see? Like, do you want to like write out all the numbers for each entry and then?
I would at least write this right here. That way, if you make one little mistake, we can catch it, okay? And then if it's like a quiz or test, I can give you some partial credit, okay? On a problem set, you definitely would need this. Now, can you check it with your calculator? Yeah. You can enter in matrix A, enter in matrix B, and then you can call up A times call up B. If you want to check your multiplication, especially on those even problems, that would be good calculator practice. Okay. Now I do want to talk about a word problem, okay, because we can use matrices to help us out. Okay. So 2 softball teams submit equipment lists. Each bat is $80, each ball is $6, and each glove is $60. What's the total cost of equipment for each team? Now I know that you can figure this out without a matrix. I know. Okay? But let's just use the matrix and multiplication to help us out. So here I have a table for you. Oh, can I move it? I guess I can't move it. All right. So I'm going to make a matrix. 12, 15, 45, 38, 15, and 17. What do our columns stand for? Women's and men's. And what do our rows stand for? bats, balls, and gloves. Okay, now if we want to figure out the cost of each team, we want to end with a matrix that's about money and women and men, right? So we need to multiply this by a matrix that deals with how much money it is for each bat, ball, glove, right? So I have bats, balls, and gloves and how much they cost. Do we want to write a 1 by 3 matrix or a 3 by 1 matrix? We want a 3 by 1. Do you agree with him? We would want a 1 by 3, right? If we have a 1 by 3 and a 3 by 2, we'd be able to multiply those together. So we can write a matrix about the cost of how much is a bat? 80. Each ball is, and each glove is 60. So now when we multiply row times column, we're going to end with a what order of a matrix? We're going to end with a 1 by 2, where it's going to deal with money, women, and men. So let's do that. Row times column. What is 80 times 12? 6 times 45. And 60 times 15. What? So there's one entry. And then row times column. So 80 times 15, 6 times 38, 60 times 17. Okay, we put that there. Is that what you would do anyway? Right? And you add them all up so you get, do I even have the answer? Yep. Okay. So there's how much the women's teams cost. There's how much the men's team costs. Of course, men cost more. They're more high maintenance than women when it comes to sports. Okay, here's your homework. This is super important. You have to practice matrix multiplication. Okay? When we were doing matrix addition, you were probably thinking, oh my gosh, this is so easy. Matrix multiplication, you have to practice. It is not difficult, but if you do not practice it, you will not remember how to do it.